Let's dive right in. Every single time the wind blows across the landscape, we're literally surrounded by an invisible ocean of kinetic energy. In today's explainer, we're going to unpack exactly how enormous machines quietly capture that moving air and somehow transform it into clean electricity capable of powering entire cities. It's a pretty fascinating question, right? Because from a distance, they just look like simple pinwheels spinning lazily in the breeze. But to truly understand how invisible wind becomes the electricity flowing into your home, we've got to take a journey from the massive scale of the sky right down to the microscopic movement of electrons.
Here is our blueprint for today. We'll start with wind into motion, step inside the machine, look at controlling the giant, follow the energy to your home, and finally, wrap up with the true scale of it all.
Okay, Section 1. Wind into motion. To really get this machine, we first need to ground ourselves in the fundamental physics. Wind is simply moving air, driven by the Earth's rotation and pressure differences. Warm air rises, cool air rushes in to replace it, and boom, you've got a moving mass of kinetic energy.
Now, the math behind wind power is actually incredible. Power is proportional to the cube of wind speed. That cubed part is absolutely crucial. It means even a tiny little breeze picking up creates an exponentially massive jump in potential energy. Stronger winds don't just give us a little more power, they give us exponentially more.
So how do we actually catch it? Well, think of a regular household fan. You plug it in, it uses electricity to turn the blades, and that creates wind. A wind turbine does the exact reverse. It's the complete opposite mechanism, capturing the motion of the wind to create electricity.
But here's the thing. Those blades aren't just flat boards catching the breeze like a ship's sail. They actually act exactly like airplane wings. They have a highly specific twisted airfoil shape, so as wind flows over them, it creates low pressure above the blade and high pressure below it. That pressure difference creates aerodynamic lift, and it's this lift that efficiently drives the rotation of the entire massive rotor. Moving right along to Section 2, inside the machine. Let's step off those spinning blades and head inside that protective casing at the top of the tower, the nacelle, to track where all that mechanical energy goes. All those massive blades transfer their combined force to a main shaft. Now, despite capturing all that immense power, that shaft only rotates at about 15 RPM. That is sluggish. We're talking slower than a casual bicycle ride, which is just way too slow to generate electricity efficiently. Because 15 RPM won't cut it, that low-speed shaft feeds directly into a gearbox. By using an intricate system of interlocking gear teeth, it multiplies that sluggish rotation, stepping it all the way up to a blistering 1500 RPM on the output shaft. It literally takes immense, slow torque and converts it into pure speed. And that high-speed shaft, it plunges straight into the generator. This is where electromagnetic induction happens. Basically, Faraday's law in action. We use that high-speed mechanical energy to spin really powerful magnets inside a cylinder lined with copper coils. That moving magnet creates a changing magnetic field, exciting the electrons in the copper. And just like that, the kinetic energy of the wind is finally electrical current.
Section 3. Controlling the giant. Nature is totally unpredictable, so let's look at the smart tech required to keep this spinning leviathan safe and highly efficient, no matter what the weather throws at it.
Turbines are incredibly dynamic. They rely on two main control systems. First up is the yaw system, which physically rotates the entire massive nacelle so the blades are always facing the changing wind direction. Then you have pitch control, which rotates the individual blades on their own axes to either catch the maximum breeze or back off during intense winds.
Pitch control is actually a vital safety mechanism. If a severe storm rolls in, the turbine protects itself by pitching the blades completely flat, basically feathering them, so the wind just slips right by. Combine that with heavy-duty hydraulic emergency brakes, and these redundant systems are what keep the machine from spinning out of control and completely destroying its own gears.
Section 4. Energy to your home. The electricity is generated, the turbine is optimized. Now we just have to follow those electrons on their journey out of the sky and into your living room.
The raw electricity coming straight out of the generator isn't quite ready for your home yet. It has to travel down the tower to a power converter to smooth out the current, and then it hits a transformer. By dramatically bumping up the voltage, we can push this electricity efficiently across miles and miles of the high-voltage grid without losing power, before stepping it back down at a local substation for you to use.
Section 5. The True Scale. For our final section, let's zoom all the way out to appreciate the staggering dimensions and the real-world physical limits of these modern marvels.
You'd think a perfect turbine would capture 100% of the wind's energy, right? Actually, it can't. If it did, the wind would stop completely right behind the blades, creating a literal wall of static air that blocks any new wind from entering. Physics caps the theoretical maximum efficiency at 59.3%, known as the Betz limit. Yet modern turbines are so incredibly well engineered that they capture around 45%, brushing right up against the boundaries of what is physically possible.
And to reach those premium, super smooth winds higher up in the atmosphere, we have to build to an awe-inspiring scale. A modern 5-megawatt turbine has blades about 80 meters long. That is nearly the length of an American football field. The tower is 120 meters high, and the whole thing weighs hundreds of tons. Yet it balances perfectly on a single column to power thousands of homes.
So what appears to be just a simple pinwheel on the horizon is actually an extraordinary symphony of aerodynamics, mechanics, electronics, and physics. Every single rotation is this elegant dance between nature and engineering, working in perfect harmony.
Honestly, understanding the sheer ingenuity inside one of these machines completely changes how you see them. As we continue to push the boundaries of clean energy, it leaves us with an exciting thought to close out our explainer today. What other incredible invisible forces are just waiting out there to be captured? Thanks so much for exploring this with me today.